Hello and welcome. This video tutorial will serve to help you with Newton's first law problems, static equilibrium. Today we're going to be looking at three questions: static equilibrium level 1, 2, and 3. In these problems, you're going to be asked to find what are called vector components. So we're going to do a very brief review of how to resolve a force vector into its components, okay? And then we're going to basically apply these with tension forces that are pointing at certain angles. You are going to be required to do a little bit of substitution algebra with systems of equations. That means we will solve for one variable in one equation and substitute the value of that into another equation. You'll see what I mean when we get there. Please make sure that you pause the video as needed. And if this, still does not serve to help you get over the hump and be able to understand how to master this particular concept, make sure that you come and talk to me about that. Okay. All right. So let's go ahead and begin. Our first question is static equilibrium level 1. Now, one thing that I want to point out to you, I'm going to just add a page right here, just so that I can kind of go over a few notes with you before we begin. Okay. So a couple things to note. Okay. When we're doing forces at an angle, okay. So let's say, for instance, I have a force vector that is at some angle theta above the horizontal. Okay. So this is my horizontal. Okay. And this is my, basically my force vector is at some angle above my horizontal like that. Well, what I want to do is I want to take that and for the sake of doing this, I'm going to call it tension today because that's the vector you're going to be working with as a tension force, but it could be any force vector. Okay. Let's work with tension right now. Well, the idea is you want to resolve this into its components. So remember, we did this work a few weeks ago when we worked with vectors, but now we need in projectile motion and the horizontal and vertical components of velocity, but we need to use it again. Now, here's how this will work. Go ahead and give this different colors. You can see my black vector tension has a blue horizontal component, okay, and a yellow vertical component. Okay, now I'm going to go over a couple different ways to describe this, okay? So I've got two very similar angles, but I want to make sure that we're comfortable doing this, okay? So I'm going to set this up twice. Just bear with me, okay? We'll see why. Okay, so let's say that this right here is my angle theta, okay? And it's down here. Well, that makes this side the adjacent side of the triangle. That makes this side the opposite side of the triangle. And opposite always goes with sine, and adjacent always goes with cosine. So the way we would write this is the blue component would be the hypotenuse, which you can see is the tension vector here. You do see the right triangle, this side, and this side. Well, the tension is the hypotenuse of that triangle. So I would go the hypotenuse, tension, times the cosine of my angle, just like that. That means the yellow component would be tension. Well, I shouldn't write that in yellow. You can barely see it. It would be tension times the sine of the angle. So notice what I'm doing here. I'm going to apply the hypotenuse tension for both sides. The adjacent side is your hypotenuse times cosine. Your opposite side, that's your hypotenuse tension times sine. Okay, so that would be, we would approach it this way if your angle was down here. There's the opposite side, there's the adjacent side. But what if your angle were, let's say, up here? Let's say that was your angle theta. Well, now this becomes your opposite side, right? The blue is now your opposite side, and the yellow is now your adjacent side, which means follow the same rules. Adjacent goes with cosine of an angle, and opposite goes with sine of an angle. So the yellow component would actually be tension times the cosine of the angle this time. And the blue component here would actually be tension times the sine of the angle. That's all you guys have to know when it comes to using right triangle trigonometry. It's really simple. If you can identify the opposite side, 100% of the time, it will go with sine of the angle. If you can identify the adjacent side, then 100% of the time, it will go with the cosine of the angle. Okay, so I just wanted to make sure that I address this with you because you're going to need this knowledge base when it comes to doing what we're going to do today with this lesson. We're going to have to take our tension vectors and resolve them into their vertical component going up and down and horizontal component going side to side. Okay. Now, the PDF will tell you to resolve it into T1x or T1y or T2x. I mean, we can do that, but we don't really need to do that. We can just make sure that we focus in on what the actual components are in terms of the sine and the cosine of the angle. Okay. Now, another thing we're going to need is the following. So let's go to the top of our page. Keep in mind static equilibrium. Okay, what that means, it means not moving. That's what static equilibrium means. It means not moving, which means you're not accelerating. Now, one of the things we're going to do is we're going to apply all of motion into one of two categories. Write this down, please. All of motion falls into one of two categories. If you are accelerating, then you will apply Newton's second law of motion. And I'll show you how to do that next week. We're not ready for that just yet. But that happens if you are accelerating. That means if you're changing your velocity. Well, what's the opposite of accelerating? Not accelerating. That would be if you're moving with constant velocity or you're not moving at all. Velocity equals 0. And that's exactly what we're doing now. We're not moving with static equilibrium. So how are we going to apply this right here? Well, we're going to apply Newton's first law of motion. So you guys see I abbreviate this Newton's first law, I abbreviate it as N1L, and Newton's second law, I abbreviate that as N2L, okay? How do I apply N1L? Well, we're going to apply that in forces going up equal forces going down. U stands for up, D stands for down. Or forces going left equal forces going right. So forces right equal forces left. Okay? In other words, the way we apply Newton's first law of motion is we set forces that are opposite to each other equal. Remember, up is opposite to down, and right is opposite to left, right? We would set those forces equal to each other also. So it depends on, and we have to analyze the direction, of course, right? If we are not accelerating vertically, right? If we're not moving vertically, then up would equal down. If we're not accelerating horizontally, then forces right will equal forces left. Well, since you're not moving in this entire exercise, then guess what? You're not going to be accelerating in the horizontal or vertical direction. So we will be applying up equals down, forces up equal forces down, and we will be applying forces right equal forces left. So we're going to do all of that today. All right, y'all ready? Okay, let's begin. I think we've got enough to go ahead and get us started. So step one, we have a picture showing T1 is the tension force at an angle, and T2 is a horizontal rope with horizontal tension. Okay, we need to fill in the mass of our object and the angle with which the rope is made. So everybody go ahead and put in your name into the program so we can begin this. All right, so my mass you can see is 1.3 kilograms. Go ahead and write your mass. Okay, 1.3 kilograms. And you'll also be given your angle. My angle is 48.4 degrees, and that angle is going to be made with the vertical right here. So 48.4 is my angle. That's your theta, okay? All right, so we got that written down. All right, now what we're going to do in step two is we're going to write the vector components for, well, in step one here, let's actually draw the forces. Let's draw the forces acting on this mass here, okay? Now you remember when we did our free body diagram lesson and activity, we practice drawing the forces on what would be the center of mass of an object. Well, one force acting on this mass would, of course, be the weight, the gravity. So let's draw a force vector straight down. Okay, like this. And we can label that W equals mg. Now, if you want to, you can, instead of W, you can write F sub g. That's gravitational force. That's fine. Either one is fine. But we have this, and we can calculate it. Okay, we can calculate the weight. So force sub g, or weight, whichever you want to call it, is equal to mass times g, which in my case is 1.3 times g, which is 9.8. Remember, g on Earth, the gravitational field on Earth, on the surface of the Earth, is 9.8. On another planet, right, you would have a different value. And I don't think, I'll double check right now, but I don't think that this takes place on another planet. I think this is meant to take place on Earth. Yeah, we're not told. Yeah, see, rope one, it gives you a color code, by the way. Rope one and rope two, you can see rope one is the one at an angle, rope two is the horizontal rope. But no, I can't see any indication that this is anywhere else. So this is going to be a gravitational force equation on Earth, 1.3 in my case, times 9.8 is 12.74 newtons. I want you guys to take a moment and figure out the gravitational force for your mass. Okay, now that you did that, we need to focus on the tensions now. Well, tension is an easy force to draw. The way we draw tension is we always draw it away from a mass. The reason why is ropes pull objects. You can't get a rope to push anything. Ropes always pull things. So we would have a rope pulling to the right, that would be tension 2, and we'd have a rope pulling up like this, up along the rope like that. That would be tension 1. Now you can see tension 2 is already horizontal, so I don't need to do anything with that. But tension 1, however, tension 2 being horizontal, tension 1 is pointing up and to the left. So what we're going to do is we are simply going to go to the left and up. So choose 2 different colors. I'm going to go to the left like this, and I'm going to go up like this. So I'm using blue and red to complete my components. And you can see, guys, we create a right triangle where T1 is the hypotenuse. The blue component is the opposite side of theta. And the red component that I drew here is the adjacent side of theta. Okay, so now we're ready to do our components. And what I'm actually going to do is I'm just going to kind of select this work right here, and I'm going to see if I can copy it. Yeah, there we go. Okay, so I got some of it. There we go. I don't know if I can make that bigger. No, never mind. I should just redraw it again here. I'm trying to be all fancy and just kind of wasting time. Let's redraw that again. So I've got my tension 1. I've got my tension 2. I've got my weight going straight down. Weight equals mg. And you saw me make tension component going to the left, and then another tension component going up right here. And this is my angle theta right there. So what I'm going to do is I'm going to find the components of T. Well, remember, the blue is the opposite side, right? I might even label that just to keep my brain attached to it. So this is the opposite side, and opposite goes with sine. So since the hypotenuse is T1, the blue component, or the blue side of this, would be T1 times the sine of theta, my angle. And remember, your angles are given. My angle was 48.4. We'll put in that angle later. Okay, right? Angle theta is 48.4 degrees. I'll put that in later. Okay, now my red component, you can see that's the adjacent side of the triangle. And the adjacent goes with cosine. So that side would be T1 times the cosine of my angle. Okay? So that's what I'm trying to do, is I got to start by taking any force that's at an angle, and I need to resolve it into its horizontal and vertical components. The red one is my vertical component. The blue one is my horizontal component. Okay. Now what I'm ready to do is I am ready to, I can find, um, I can basically start applying my Newton's laws, okay? Now, I'm only applying Newton's first law in this whole entire work because the object and mass is in static equilibrium. It means it's not moving. So how do I apply Newton's first law? Well, in the case of force vertical, that's what FV stands for vertical forces. Forces going up, FU would be able to, so force up would equal force down, right? Force up equals force down. Now, what force is going up? Well, that would be the red component right there, T1. So I would replace this with T1 cosine of my angle. And force down, well, that would be the weight. And we already calculated that. The weight was what you calculated here. Mine was 12.74. You can see very easily I can solve for T1 by just simply dividing away the cosine of the angle, and I will get T1 all by itself. T1 would be the weight divided by the cosine of your angle. So I'm going to go, in my case, I'm going to go 12.74 newtons divided by the cosine of, looks to be 48, just double check, 48.4. So T1, 12.74 divided by cosine 48.4, 19.2. 19.2 newtons. Okay, got that? Make sure you pause the video and find your tension one. Okay, now how do we find tension two? Well, this is where we can start applying Newton's first law for horizontal forces. Okay, so force horizontal, we're still going to apply Newton's first law, but this time it's going to be forces going right equal forces going left. The force going to the right is T2. The force going to the left is T1. It's the blue component, T1 sine of the angle. So force right, that would be T2. Force left would be T1 times the sine of the angle, okay, which we can plug in because we've got the value for T1. So my value for T1 was 19.2, and I'll multiply that times the sine of my angle, which was 48.4. So 19.2 times the sine of 48.4, and I'm getting about 14.4 newtons of tension. So what we're doing in this problem is we're doing a bit of what's called substitution algebra, okay? This is called a linear system of equations. We call it a system of equations because you have two equations, one in the vertical direction, up equals down, and one in the horizontal direction, right equals left. Okay, and with those two equations, you had to solve for two unknowns, T1 and T2. Okay, so that's the basic math behind what we're doing. Now, let's go ahead and enter it in our program and just make sure we're doing it right. So I'm getting 19.2 and 14.4. Let me just double check. Looks good. All right, there we go. Pretty close. My answers are correct enough. And hopefully you were able to get this correct yourself. If so, let's move on to question number 2. In question number 2, you're going to have two tensions at angles. Tension 1 is pointing up and to the left like this. Tension 2 is pointing up and to the right like this. You'll be given these angles here, and you'll be given the mass, which we'll write down. Okay, so let's go to our program. Let's put in our value. Now, it does say that both ropes are pulling at the same angle. That's a pretty big hint. I'll tell you why in a second. Okay, so let's record our stuff. My mass is 7.6. There we go. And my 46.2 is my angle. 46.2 degrees, 46.2 degrees. Okay. And what I'll do is I'm going to go down. I've got my information there. I got to be able to find force gravity, so I'll do that. I'll find my weight. Remember, weight is force gravity. Okay, and it's m times g, so I'll go 7.6. And again, this is on Earth, mind you, so use g as 9.8, okay? So find your weight, 7.6 times 9.8. So in my case, the weight of that mass is 74.48. Okay, so make sure you find yours. Okay. And again, we have to enter tension one and tension two. So the weight is part of the calculation. It's not the finished answer. So now on this picture here, let's go ahead and resolve that into its components. So I got weight equals mg, which you should have just calculated. In my case, it was 74.48 newtons. And you had the tension 2 going up this way, and you had tension 1 going up that way. Now resolve them into their components. I'm going to go the blue direction. I'm going to go horizontal in the blue direction. I'm going to go vertical red. Choose whatever colors you want. Okay. This is my angle theta. This is my angle theta. And my angle theta, according to this, for my problem was 46.2. So I'm just going to write that here above so I can insert that number later. 46.2 degrees. Okay, what are my components? Well, just like last time, the blue component is opposite, and opposite goes with sine. So that makes the blue component T1 sine theta. But that makes this component also, this one would be T2 sine theta. Now the red components, if you remember what we did in the last problem, the red components are the adjacent side of the triangle. That makes them attached to cosine, and that component would be T1 cosine of theta and T2 cosine, oh, not sine, sorry, cosine of theta. Okay, now here is where we can use this conceptually. If these angles are the same, that means these two tensions will be the same. That means we don't need a T1 and a T2. We're just going to call it T. Okay, so let's make a note of that right now, everybody. Since the angles are the same, since theta 1 equals theta 2, tension 1 will equal tension 2. So all we have to do is solve for tension, which is just going to be tension, okay? Solve for tension, and that's going to be the same as tension 1 and tension 2, okay? So I'm gonna kind of erase all the T1s and T2s everywhere because we don't need that. It's the same tension. So it's tension cosine and tension sine. Now you'll notice something about the blue vector. The blue vector in both cases is opposing each other. And if it's the same angle, T sine theta equals T sine theta, that's going to cancel. So horizontally speaking, force horizontal, we have force right equals force left, which means T sine theta equals T sine theta. I mean, that would just divide out and give you a 1. I mean, that doesn't help anything because it's going to cancel, right? So it's going to cancel. So I'm not going to worry so much about the vertical side. I wrote vertical for some reason. I'm sorry. Horizontal. Those are X direction forces. Now force vertical, okay? Force vertical would look like this. Force vertical, I have tension cosine. That's one force going up. Okay, because remember, I'm going force up equals force down. Well, if you notice, guys, I have two forces that are going up, tension cosine on the left and tension cosine on the right. So I have, for force up, I've got tension cosine plus tension cosine. of theta equals force down, which is your weight. So if I add these together, tension cosine plus tension cosine is 2 times tension cosine equals the weight. Let's use this to solve for tension. I'm just going to kind of pull that down here so I can do my work. So 2t cosine theta equals your weight. And let's solve this for tension. To get tension by itself, you're going to divide by 2 times the cosine of your angle, just like that. Cancels, cancels, cancels. T is by itself. And it's going to be your weight, which in my case is 74.48 newtons, divided by 2 times the cosine of the angle. Now, what's really important is when you put this in your calculator, put this number, okay, hit divide, and then immediately open parentheses 2 cosine theta, but then close parentheses after all of that, because when you do cosine, it'll probably have cosine and then parentheses for your theta. So just make sure you're closing parentheses for the whole bottom, and that way your calculation will be sound, okay? But go ahead and pause the video and make sure you find your tension. All right, I'm getting a value for T, which is T1 and T2, at about 53.8. And there you go. Tension 1 equals tension 2. Since it is the same angle, both tensions will be the same. Hopefully, we're able to get this right as well. Okay, if so, on to question number 3. Now, you're going to have a similar problem to number 2, but the difference now is that the ropes will be pulling at different angles, which means you will legitimately have a different T1 and different T2. Let's see what we do with that. First thing I'm going to do is I'm going to fill out, when I put in my name here, I'm going to fill out the information provided. So I've got a mass of 3.2 kilograms. I have one angle at 43.3. Tension 2 on the right has an angle of 43.3. So it's a little bit wider. 43.3. And my angle to the left for T1 is a little smaller, 33.5. Okay, you will probably get different values than I did. Well, you'll definitely get different values than I did, but just make sure it doesn't matter if the first angle is bigger or smaller, it'll still work the same. Just make sure you note what angles you're working with. Okay, I'm working with 33.5 and 43.3. Okay, so first thing I need to do is find the force gravity on the object, just like we've been doing. So weight equals mg. Take my 3.2 kilograms times 9.8. Okay, and I'm going 3.2 times 9.8 is 31.36 newtons. Okay, so I got that. Now what I'm going to do is I'm going to take that picture, okay, and let's find the forces on here. I've got tension 2 pointing this way. Got tension 1 a little bit more up like this. And I've got weight going straight down, which I already know because I calculated it. Same thing, I'm going to go blue going to the left and right, my horizontal components, and red going up vertical like that. Okay, now since this is T1, I'm going to call this theta 1. And since this is T2, I'm going to call that theta 2. Okay, so here we go. The blue component down here is the opposite side of the triangle. So that would make this T2, not T1, T2 times the sine of the angle, theta 2. At this moment, pause the video and try to figure out what this component, and this component will be so that you can finish this problem. Okay. What we have for this red component, since it's the adjacent side, would be T2 times the cosine of theta 2. This blue component, since it's the opposite side, will be T1 sine of theta 1. And this red component will be T1 cosine theta 1. Okay, here's what I'm going to do to begin. So I'm going to start with my force horizontal because there's only two forces. And then I'll go with force vertical, which there are three forces. There's two forces going up and one force going down. Okay, so now let's start with force horizontal. Okay, what do I know? Force horizontal, if I'm applying Newton's first law, would tell me forces going to the right equal forces going to the left. Well, the right force is T2. Now this is where I'm going to plug in my values. The sine of theta 2, my theta 2 is 43.3. So T2 sine of 43.3 equals my force going to the left. So this is my force going right. My force going to the left is over here, and that's T1 sine of theta 1. T1 sine of, my first angle was 33.5. Okay, so just make sure you note your angles. Okay, just like that. Now, before I continue with vertical forces, I'm going to pick a variable to solve for. All right. Now, what I'm going to solve for is, in this case, I'm going to solve for T2. Now, I can do that by dividing by sine of 43.3 because that will help me get T2 by itself. So let's do that. T2 is going to be T1 times that ratio right there, sine of your two angles divided. Okay, so T2 is going to be, now if I put in my calculator the sine of 33.5, divide that by the sine of 43.3, I'm going to get 0.805. So when I divide those two right there, I want you to divide yours. Divide your ratio of sine values, okay? I'm going to get 0.805. So write down what you get and multiply that times T1. So T2 equals 0.805 times T1. That's going to be my first equation. Okay, that's my first equation that I'm working with. Now I'm going to go force vertical. I'm also going to use Newton's first law, but this one will be forces going up equal forces going down. Well, I happen to have two forces going up. T1 cosine theta 1, T2 cosine theta 2. So I'm going to write those values in there. T1 cosine 33.5 plus T2 cosine of theta 2. Theta 2, if you remember, was 43.3 in my case. Write down yours. So T1 cosine of the first angle plus T2 times cosine of the second angle equals force down. Well, the only force going down would be your weight. In my case, the weight was calculated at 31.36. Okay, figure out yours. All right, now what I'm going to do is I'm going to take the cosine of those numbers. I'm going to write them as decimals, okay? So I'm going to go cosine of 33.5. And when I do that, I get 0.834. So that right there, cosine of 34 is 0.834 multiplied times T1 plus, now I'm going to take the cosine of that angle. Cosine of 43.3 is 0.728. 0.728 times T2, so I'm going to write that next to it, equals my weight, 31.36. Now, I'm going to take both, that's going to be my second equation right there. I got two equations, two unknowns. What I will do, and I'm going to do this down in step 3 down below here, I'm going to take the value for T2 and I will substitute that into, the value for T2 is 0.805 T1, and I'm going to substitute that right down here in place of T2, the variable. And that will allow me to have one big long equation with just T1 in it. Okay, so let's try that. I'm going to take my big long equation here and I'm going to write it down. So I've got 0.834 T1 plus 0.728 0.28. Open the parentheses now so you can substitute for T2. Okay, now my value of T2 was 0.805, 0.805 times T1. And then you'll set that equal to your weight on that backside of the problem. Okay, now we're almost there. Now we just got to multiply those two numbers. Okay, 0.728 times 0.805 in my case. So we're going to 0.834 T1 plus 0.586 T1 equals 31.36. You now have like terms, right? T1 and T1, you can add them. So 0.834 plus 0.586 is 1.42 times T1, and that equals 31.36. Now you can divide by that to solve for T1. Okay, so T1 in my case is going to be 31.36 divided by 1.42. That would be 22.1 newtons. Now to get T2, this is extremely easy because you have a very simple equation for T2. T2 is just going to be some decimal times T1. In my case, 0.805. So 0.805 times my value for T1, which was 22.1. Plug that in. 0.805 times 22.1, and I'm getting about 17.8 newtons. Okay, let's double check these. $22.1 and 17.8. There you go. All right, so you can see this required a little bit of substitution algebra to be able to do it. If you take it in small bite-sized steps, it is doable. I know this is complicated because this is new for many of you, but take it in smaller bite-sized pieces, okay, as I did. Try to practice this yourself so that you can gain confidence and mastery of this skill. Of course, if you're still struggling on understanding parts of this, write question marks next to parts of the video that you don't quite get, and then come and see me about it, and we'll help straighten that out for you. I hope you found this to be helpful. We'll see you next time.